Mr. B, and we're going to do our notes this way this time because I know a bunch of you needed to finish up on your labs, your difference and density labs. So instead of me presenting the information in front of the class, I'm going to share it with you this way. So please treat it as though I'm presenting it in front of the class. So you're going to be writing everything down just like you normally would. And the title of the section is Modeling Deep Ocean Currents. So I would start a fresh sheet of paper where you last left off with your notes. And make sure you're writing everything down because you know that you'll be able to use them for a little bit on your test and quiz. Okay, so the title of the section, Modeling Deep Ocean Currents. So in the previous section, we talked about how surface currents are created by global winds. And those global winds are going to cause the surface ocean currents to move. Some of them are going to get deflected because of the continents. They're going to bounce into them and get deflected or turned around. But also because of the Coriolis effect, they're going to get turned as well. Now, those are the surface currents, the ocean surface currents. But below the ocean surface, towards the ocean floor, we see that there's another type of current that is very, very cold water. And it's going to be moving across the ocean floor. And these deep currents are caused by differences in the density of the ocean water. So if you remember when we did our rainbow lab, we looked at the different colors and how they stacked up on each other. So if you can picture that, you can kind of envision what it would be like in the ocean where you have different densities of ocean water. And just like we saw with the different colors, there's going to be more density towards the bottom, less at the top. Now, the density of water depends on its temperature and its salinity, which is what we were doing in our experiment. We had hot and cold water with different amounts of salt to see where it would be in the water column. And we discovered something through that. And we'll talk about that when we go over the lab together. Now, the warm surface currents, so if you picture at the surface of the water that's getting moved by the global winds, so our polar easterlies, our prevailing westerlies, and our trade winds, they're going to move from the equator towards one of the poles. And as it moves towards those poles, it's going to get cooler and cooler and cooler until eventually it becomes cold. Now, some of that water that has moved from the surface current, so picture it moving towards the poles, is going to form into ice. It's going to help make some of the polar ice caps or glaciers. And what's going to happen is that that water that has salt in it, that salt is going to get left behind. And so we talked about how, like near the poles, it may be a little bit of a more saltier or have a higher salinity near that area. And it's because of the fact that some of that water is freezing. Now, as the temperatures decrease, so as the temperatures get colder, its salinity, the amount of salt, is going to increase. And that water is going to become more dense because it's going to be heavier with all of that salt. And it is going to sink down towards the bottom of the ocean floor. Then that cold water is going to flow back along the ocean floor as a deep current. And because of the Coriolis effect, it's going to cause it to turn. Right? So if you picture this, you got these surface currents that are going towards the poles. Some of that water is going to freeze. It's going to be a very high amount of salt. It's going to get forced down towards the bottom of the ocean, and then it's going to come back to flow back towards the equator. Okay, and part of that's due to the Coriolis effect. Now, deep currents move and mix water around the world. Okay, so this is one of the ways that we kind of mix up the ocean. They carry cold water, sorry about the typo, but it's from the poles towards the equator. These deep currents are moving very slowly. Okay, so this isn't something that happens very fast. It may take like 1,000 years to flow from the pole to the equator and back again. So if you picture this, it's just like this kind of conveyor belt where it's moving from the equator all the way to the pole where it gets heavy, gets forced down, and then it slowly makes its journey back towards the equator and kind of mixes up the water. So that is a deep ocean current. Now, another term is called upwelling, which is the movement of cold water upward from the deep ocean. Okay, so this is kind of that process where, again, the wind blows away the warm surface water. Okay, it moves towards the poles. The cold water, and again, I have a typo, rises to replace it. Okay, so you see that the surface currents that are warm are getting moved. It's kind of like the concept that we had talked about with convection currents. You have this warm water that's moving towards the poles. You have the cooler water that's coming up and replacing it. Water will get warmed and eventually moved on. And so, again, what you have going on is you have these surface winds that are blowing and it's pushing away that warm water, which is going to move towards the poles. As this warm water gets moved, the cooler water comes up, gets heated back up again because of the sun's energy, and it is going to get moved on. And so, as this happens, we see that this motion is going to produce or bring up tiny organisms, minerals, and other types of nutrients from down towards the deep layers of the ocean. And without this motion, the surface water of the ocean would be very scarce of nutrients. So this kind of mixes it up and creates kind of a system where there's both organisms, minerals, and nutrients that are circulated throughout the entire ocean. Now, if you can kind of picture this again, remember the surface currents move towards the poles, they begin to get cold, some of the water will freeze, but it has a lot of salt that's here, and that salt and water that is going to get forced down and it's going to begin to move back towards the equator. As the surface wind begins to blow, it's going to get forced back upward, and we call that term upwelling. Okay, that is it for your notes. So make sure you have everything copied down. There is a video that you need to watch after this, which is going to be on the Google form as well. And when you're done, you can move on to your homework, which is your textbook work, which in the beginning of the class I will have shared with you what you need to do for that. Okay, if you have any questions or you're unsure of anything, our next class I'll ask if you have any questions or if there's anything that you need help with understanding from the previous section or this section that we had gone through. Okay, I hope that makes sense, and we'll talk to you later.